David Smith here with another Flip Classroom math lesson. 3 tips before we start. First, you can adjust the playback speed to suit your ability to consume the video. Second, you can pause the video at any point to catch up with your notes or jot down questions. Third, you can turn on the captions and read my words on the screen. Today's topic, one-sided limits. Okay, so we're going to tease out limits that don't exist from both sides, and we're going to look at them from one side. So you'll remember in earlier lessons we talked about when f of x approaches different numbers from the left and right, from the negative and from the positive, when it approaches different numbers, we said the limit fails to exist. So now we're going to look at limits approaching from one side and limits approaching from the other side. So it's still useful mathematically to be able to evaluate functions that have limits that exist only on one side or the other. So check this out. Some notation here. The limit as x approaches c with this little negative sign, that means as it approaches c from the left of f of x equals L. So there's some limit there. We can write that. We're going to say the limit exists from the left. In a similar way, at the limit as x approaches c from the positive side, from the right, f of x, we have a limit L. So this limit exists from the right. Okay, here's a function that involves absolute value. If you remember, we did one of those before and it had a limit that failed to exist. So now we're going to tease that out a little bit and talk about the limit of this particular function as we approach from the left and from the right. So here's our function, f of x equals the absolute value of 2x over x. And we're going to evaluate from the left and the right as x approaches 0. So obviously we can't plug 0 in because we'd have divide by 0 problem. So we need to approach from the left and right and see what happens. So what I want you to do right now is pause the video and get out your calculator, pop into Desmos, however you want to do this, but evaluate this limit from the left and from the right. Okay, so I made my t-chart with my function, plugged in some values, and what I get here is I'm getting closer and closer to 0 from the right to 1.1. F of x stays at 2. Okay, so that's telling me that my limit is most likely 2 here. Now, as I approach from the left, forgot my negative signs here. From negative 2, negative 1, negative 0.1, the function gives us negative 2, negative 2, negative 2. So that looks like my limit from the left is negative 2. So before we write the notation for these limits, I want you to pause the video and create the graph of this function, just so you can see what's happening there. Okay, here's what you should get with your graph. When we're to the right of the y-axis, when x is positive, f of x is 2. But remember, we can't put 0 in, so we put a circle around when x is 0. Now it's real similar, just negative 2 for approaching from the left. We have a circle out there, and we go that way. So there's the function. It's non-continuous, right? We have a break here. We can't put 0 in our function, so it just doesn't have a value there because it's undefined. Okay, now what I'd like you to do is take a stab at writing the notation expressing the result of this problem. So your limit notation with the little plus or the minus and the result of your limit. So you'll have to look back through your notes to do that. Okay, let's see how you did. So this one is limit as x approaches 0, let's say from the right first, of absolute value 2x over x, that equals 2. So that expresses that limit. As we approach 0 from the right, our limit is 2, and similarly, the limit as x approaches 0 from the left of 2x over x, that equals negative 2. Okay? Okay, so now we're going to take a problem where we approach a limit from both sides to test to see whether we have a full limit where it reaches the same number or whether we have a left side and then a right side limit. But we're going to add a new twist to this. Our f of x, our function, is going to be a composite function. And so that adds a layer of complexity. You just have to keep track of what you're doing. I think it's pretty straightforward, and once you're used to it, you're going to master this. So here's our function, f of x. But the function has some rules here. It's actually 2 different functions. That's why it's called a composite function. So when x is less than 1, our function is 4 minus x. So whenever you're putting in a number for x that's less than 1, you use this function to find your f of x. Similarly, whenever x is bigger than 1, then you use this function, 4x minus x squared, to figure out what your f of x is. So this one is a nice function because, remember, we're evaluating it as x approaches 1. it's a nice function because we can just do direct substitution. And let's take a look at our results. So, the limit of f of x as x approaches 1, and let's do the positive. So this is bigger from the right. So as x approaches from the right, that means it has to be bigger than 1. That would be this function here. So we're going to evaluate that by putting 1 in. So that's 4 times 1 minus 1 squared. That's just going to be 4 minus 1. That's 3. So the limit of f of x as x approaches 1 from the right is 3. Now let's take a look at it from the left. Limit as x approaches 1 from the left of f of x. Now, we don't use this function. Now we use this function. And so that's 4 minus our 1. That's what we're approaching. And that's 3 as well. So we've got the same number from the left and the right. So we could say the limit of f of x as x approaches 1 equals 3. And you'll notice I didn't have to write a plus or a minus here because we approached the same number from the left and from the right. So this is a full-on limit without needing to say it's a one-sided limit. Now that you've watched the video, jot down a few extra notes or questions for our next class. You can also re-watch portions of the video that didn't go in so well the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.